Okay, so here are the answers for your DMR for today. All I gave you there are answers, and if there are questions, you certainly can discuss.
That's 50%. Any other thing than school, you just did. Oh, talk about number 50%. Yeah. 50% on the lotto. That's pretty good. You get half.
So why is -2 plus 4? It's an addition. It's an addition operation there.
Oh yeah, because I just kind of saw the two sides together and then I just made
Yep.
I just forgot to.
All right. Comments, questions, concerns, things you want to throw in there, Joe? Sure.
Wait, how come it's
For the past 4 days.
Hey guys, let's check out number 3. I think at first glance it's pretty clear that number 3 has a radical in it. And so anytime you've got one of these equations that has a radical in it, the first thing that we want to do is to try to get that radical all by itself. So clearly there's a couple of things with it, namely the 13 and the -5. What would you guys think would be the easiest thing to get rid of first, the 13 or the -5?
The 13.
13 would be easiest. Yep, agreed. So it's positive 13. So the way that I get rid of a positive 13 term is I essentially just move it to the other side by subtraction. So that would give me -5 square root of x minus 5 equals -10. And then, of course, you can see that the radical is still not by itself. We've got that -5 that we already identified there. How is the -5 connected to the radical? So we divide. So divide by -5. We get square root x minus 5 equals positive 2. And the fact that that's positive 2 is pretty important, because what are we about to do? Not square root, because the way that you get rid of a square root is not to square root it again.
Square it.
The way you get rid of a square root is to square it, right? Yes. Squaring and square rooting are opposites. So I would square the left side, that gets rid of the square root, and I would square the right side. So when I do that, I'll come up here, and I get x minus 5 equals 4. The radical and the square root cancel each other out. And then my last step would be to get the x by itself. So plus 5 to both sides would give me that answer of 9. And if you remember, with these radical equations, you always want to check them. So I think if you take the 9 and you plug it back in, you find out that it does in fact work, which is something that I did when I solved this. I thought, well, let's make sure, I'm pretty sure it works, but let's make sure the 9 works. So I plugged it in and it worked fine. Any follow-ups? Okay. All right, what else can I do? You guys do okay with the system? Number 2? Anybody else? No? Okay, fair enough. So let's talk real briefly about our week. I'm just going to use a little bit of space here. So here's how this week is going to work. I was walking in with a colleague and he said, feels like it's been a month since I've worked with students, and we thought about it for a minute. It's like it's been almost 3 weeks with those snow days and everything. So it has been a while. So let's look at our calendar here real quick. Today, Monday, we're going to do Unit 6, Day 13. What we're going to focus on today are things like the quadratic formula, remember? Slash solving quadratics in general. So that's today. We're going to focus on that here in just a second. Tomorrow we have class. It's going to be Tuesday. And what we're going to focus on tomorrow is graphing quadratics. By the way, does anybody know the name of the graph of a quadratic? Have you ever heard of this word before? Anybody ever heard of that before? Parabola? Parabola. That's a good way to remember how to spell it, right? Parabola. Parabola. And then one special note here. We did not do this. I feel like I'm going to mess up the number here.
It's 19.
Is it 19?
It's
25.
We'll say that. So the more important thing is this. Tomorrow, CQ19, that was supposed to happen on like Wednesday or Thursday of the last week before spring break, before all the snow stuff happened. And so I don't know if it's CQ19 or maybe it really is. You probably are right. This covers, the more important thing to remember, this covers the quadratic formula. So we did that a lot before break. We're going to do it again today. The good news is, maybe you're rusty, maybe you're not rusty, but if you mess it up tomorrow, you get retries. If you do great tomorrow, that's great, right? So that tomorrow, hopefully, will be a moment where you realize you're getting it. But if it's not, you'll get retries. Let's see here. Wednesday of this week, we're going to focus on graphing parabolas again. On Wednesday, we'll also be doing DMR Quiz 21, which is what you just did. So we're going to practice that again tomorrow. But then our quiz, we actually practiced it before break too, but we'll get two more this week. And then finally, Thursday, the topic of the day will be once again, how do you graph parabolas? And on that day, we have our final concept quiz. That's what happens when you have 2 snow days right before spring break.
Final concept quiz before the test?
You know what? I think graphing quadratics is on there too, so I misspoke. I think there's one more. But the test isn't for like another 3.5 weeks. So that'll be a while. Next week we'll be doing a project for a couple of days. It should be fun. So anyways, guys, that's kind of the week in a nutshell. I normally don't do this, but obviously with kind of the weird stuff that happened before spring break and then spring break. Any questions on any of this stuff? Nothing. Okay, fair enough. So then let's see how much we remember. Let's do a little practicing here. We have school on Friday? I think so. Okay, so this just kind of piggybacks off, just hopefully seamlessly as possible, kind of jumps right in where we left off, considering how we solve quadratics and what would be the best way to do it. And so I leave this one up to you for a few minutes here to kind of explore and remember and discuss with your friends and see how it goes. We'll look at some solutions. You guys are free to offer some solutions up in a little bit. Ready, set, go. Single person's paper, but the vast majority of folks that I saw did this pretty much automatically. They added the 1 over to the left side and got all that equals 0. So if you did that, that's a great first move, getting to that standard form of a quadratic. If you didn't do that, you want to be in a habit. Just like you put toothpaste on your toothbrush before you brush your teeth, not afterwards. That's a habit that nobody even has to think about. This should be something that you just do without even really thinking about it. You just get everything on the same side in descending order, just like when you brush your teeth. You really don't have to think that hard about it. That makes sense? It should just be a habit. Okay. So then, did anybody try factoring? I know a lot of people tried the quadratic formula. Did anybody try factoring?
I kind of thought through, but it didn't really work.
It didn't really work, did it? So sometimes factoring is a great move, and if you're good at factoring and this factored, then that maybe would have been the right move for you. But it doesn't factor, so it doesn't matter how good you are at factoring. It doesn't factor with nice numbers. So I don't think we do factoring. Square root property, I think, doesn't make much sense because we've got the x squared and the x. Complete the square, I think we would reserve that just for special situations at this point. But the quadratic formula should always work. So if you do the quadratic formula, you'd want to identify your a and your b and your c. They are here, here, and there. And here goes with the quadratic formula. Did anybody sing it while you're writing it down? X equals negative b plus. I like in your head, maybe. Yeah, okay. All right, here we go. Should look like this. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a.
Ba-bam.
Okay, so what do you think? Got all my parentheses in there? All the substitution looking okay? You agree? All right. So then if I do another step, I get x equals negative 2 plus or minus the square root of, oops, I lost my squared there. So negative 2 squared is 4 minus 4 times negative 5 times 1 is negative 20, all over negative 10. And then, of course, you guys know that 4 minus negative 20 is really 4 plus 20. So I would go one more step here before I switch over to the other side. Negative 2 plus or minus square root of 24 all over negative 10. So if you wrote that, you've done a lot of good work. And really, you have the answers numerically. They're correct. No issues at all. The only thing left to be done here would be some simplifying that may or may not be easy for you. So the first step in simplifying would be to write x equals negative 2 plus or minus. That radical could be simplified, couldn't it?
Yeah.
To root 6. I think you're probably, hopefully, still really good at that. Over negative 10. So there's one simplification. And if you got to that step, that's awesome. It's really good. There's one more step that's kind of a challenging one that won't always show up. It'll show up every now and then. Did you guys by any chance notice that both terms in the numerator have a common factor? They both have a 2. And so we have factored out a lot of GCFs in our time together. And so we would do this again. So the GCF is 2. What would be left over on the inside if I did factor out a 2? Negative 1 plus or minus 1 root 6, or just root 6. Oops. All over negative 10. Now here's the final simplification. Wouldn't the 2 over negative 10, like 2/10? That would simplify, right? Common factor of 2. X equals then negative 1 plus or minus root 6 over negative 5. There's other ways to write that too. You might have had possibly 1 plus or minus root 6 over positive 5. That would work too. So would you guys agree with me that last simplification, like this stuff down here, it's a little tricky? A little on the tricky side? So I'm really hoping that you got here. If you got there, I think you're in really good shape. If you manage to get all the way through to that red box down there at the end, you're in outstandingly awesome, somewhat unexpectedly, like I don't know if I would expect everyone to get there yet. It's really good though, if you got there. Joe.
So on the concept quiz tomorrow, though, would be expected to have everything in that.
If it shows up. Like I said, the stuff in the red won't always show up. Let me give you an example. For instance, if the radical number instead of a 24 was like a 31, doesn't simplify, I don't think there's going to be any of that extra simplifying like in the red box. Or if it did simplify, but then the denominator was like a 7, and that 7 was not in common with anything in the numerator, again, nothing to be simplified. So that stuff in the red box will show up every now and then, but not every time.
Okay.
So that's why I say if you can get to that check mark, I would say you've definitely demonstrated you know how to use the quadratic formula. I would be pretty happy with that.
Okay.
Yeah. Anybody else with a follow-up? Some kind of question, comment? All right, so then number 2 is our other one. If you guys would flip over and check out number 2. It's right here. I've reserved the end of our class to do a little practicing at the board, so we'll see if we get there. Please check out number 2 and give it a try.
You're a great teacher.
His version of the solution up there. Witt already put his up there, and I don't know if they got the exact same answer. I know that their answers looked kind of similar, but you're going to see that they use some very different techniques, a very different approach, and that's kind of what I want to bring out here. So do look at that, what Coy's got going on there. I think maybe I'll kind of copy down what Coy is doing, and just for the sake of the video here.
Right, exactly.
Too much.
I'm writing the same thing as Coy. I'm just basically copying him.
Breakthrough.
I love it. That was my favorite movie scenes of all time. They're in the class. Still mad. That's
No. She's actually gonna eat it. I will actually.
God, it looks like
Can I see them?
Okay. Hey guys, I think some good discussion to be had here. Listen up. I copied Coy's answers, his whole solution. You can see Witt is in the middle of the board right there. You can clearly tell that they got the same answer, right? What method did Coy choose to use? He did a good job with quadratic formula. All the steps are clear. I think it all looks pretty good. What method did Witt decide to use? And would you guys agree that similar to Coy, Witt's steps, although they look very different, are also very clear? I mean, he showed the zero factor property after he did good factoring. I mean, it's all really well done. Obviously got the same answer. So I think one of the things that's really interesting about this, I don't know why there's so many people in the hall. We go till 35, if I remember correctly. Oh, we end a little bit early. Oh, that's right, because of the thing. Don't pack the coat. Stop. Stop. Let's not let the noise in the hall be the thing that tells you what to do. I think both solutions presented here are awesome. They're great. No issues whatsoever. I also think it brings up the concept of, what do you choose to do? I don't know. Maybe some of you did the quadratic formula, and you look at Witt's, and you're like, I should have thought of that. That would have been easier for me. Or maybe it's the other way around. You got to figure out what works best for you to be able to navigate through that. So, thanks for your good work. I think you're doing really well.
Thank you, Mr. Anderson.
Keep practicing tomorrow. Thank you. See you guys.
Hey, CSS.